Right, cool. All right. Well, hi, everyone. My name is Josh Carlson. I work for Kendall County in Illinois, and you'd be forgiven for not knowing where that is. We're small, but if you go southwest from Chicago, right after the suburbs end, that's us. So decidedly rural. So farm assessments, valuations, that's pretty important to us. But where's my cursor? There's my cursor. All right, so these farm cards, that's what we refer to them as. We're talking about assessments. But I'm going to just give you some background on this project, like kind of how it started and how it's gone. I'll talk about what these things are. I gave a pre-session poll. Most of you said you're kind of just curious. I think a couple people actually work with assessments. Feel free to talk to me specifics later, but you know, this isn't a Python workshop, so even though there's probably too much Python in the slides, I'll try to keep it relevant and broad enough for everyone to get something out of it. But anyway, the background. So when I started at Kendall County, well, I should say when I accepted the job offer, between then and when I started, the other guy quit. And so this task, I was not hired to do farm assessments, but he was gone, it's required, so it landed on my plate. Farm and cards, they weren't two words I used in the same sentence, so I don't know what this is, so it's not gonna be good. But he left good notes, and the software vendor had a decent manual, so I kind of limped my way through. But, you know, I was left with this distinct impression that things have to be better than this. This is awful. So what we had, there's just this proprietary tool, couldn't see what it was really doing under the hood. It was, I say expensive, for county government, $1,000 a year is not really much, but for what it was doing, it felt like any amount of money was too much. You know, I'll pay $0 for this. It was dependent on two other pieces of proprietary software. We needed to have ArcMap and Microsoft Access. I never want to open those programs in my life, and we were not planning to support that as a department. It used a personal geodatabase. Anyone use those? Gross. So I didn't want to touch that either. It was time consuming. It took the better part of a day when the assessment office asked for farm cards for the year. And I found out later it wasn't even accurate. It was producing rounding errors, sometimes as big as a fifth of an acre. And that's money. That's people's assessments. And if they're not accurate, somebody's losing out. Either we're charging someone too much or the county's not collecting what it's owed, and no one's getting a fair shake here. So there's other stuff too, like just there's this unholy union between this tool and what the assessments folks use for their database software. And the import was overwriting deeded acreage values, which if you work with a county, like you don't touch that. You don't touch the deeded acreage, and this was overwriting them. And last year's output is next year's input. So you would get acreage values drift. And some parcels over the course of a decade or so changed by whole acres. It was crazy. And nobody noticed, but I mean, yeah, no one notices anything. Anyway, so what I wanted from a new tool, I didn't know what it was going to be or how I was going to do it, but I knew I wanted it to be accurate, obviously. If I have a number at the start, that should be the number at the end. That's math. That's easy. I wanted it to be simple. I don't want to open any other programs. I wanted it to be fast. You should be able to ask for cards for these pins, run it, send it back. And I wanted it to be accessible, so I wanted the code to be open for anyone who had questions about it. So, you know, if a farmer came and said, you know, why is my tax bill this much? None of them want to hear me say like, oh, just trust us. You know, I don't know, but we're the government, trust us. A farmer's not going to really take to that. So none of them have actually asked to see the code, but it's out there if they wanted it. And I wanted to run this anywhere. You know, I don't like booting into Windows if I can help it. So if I can run it at home, or if I can have my coworker just clone the repo and run it from their house while I'm on vacation, that's what I want. I don't want to deal with other software licenses. But to actually develop this tool, I had to actually understand what these things are. What are farm cards? We call them that because they used to be literal index cards kept in a manila folder in the assessments office. Those folders are still there, the cards aren't, but I had to really understand, like, what am I even shooting for? I knew what this other tool was doing, and I could tell it was wrong, but how do I know what's right? And the short version is, it is just how we generate property values for agricultural parcels. It's defined by the state. I can pull that up, maybe at the end, but they have this thing called Publication 122. It was like a cookbook for this whole process of how you do this. And it just breaks down to basically a spatial operation plus math. If you have an acre of rolling silt loam in corn and soy, and then you've got an acre of sandy creek bank with cows on it, those are not worth the same. But your assessor's not going to walk every acre of farmland. So the state says, yeah, it's okay to just calculate this based on intersections. So Publication 122, in nautical terms, that was my dead reckoning. I knew that, however this development process worked, whatever hurdles I was going to hit, if I knew I was just following what Pub 122 said, I'm gonna come up with the right output, whether or not it agreed with what the old stuff was. Anyway. So that was where I got the whys behind the processes, not just what they were. They call it the individual soil weighting method. There's a whole 10-step process. Steps 1, 2, 3 are just maintaining your input layers, and that's what my department does every day. It's just the boundaries, the land use, and having up-to-date aerials. And then step 4 is your intersection. It's just, that is a spatial overlay, and then steps 5 through 10 are math. So it didn't seem that hard to me, and I thought I would just tackle it however I could. I went through a bunch of different stages. I started with Model Builder, and I thought, well, you know what, it's not that complex. I don't have any parameters that are changing other than the list of parcel numbers. At one point, the whole thing was just one PostGIS query, which was kind of fun, but I needed it in a way that could work if the person didn't have direct access to the database, so they could just run it from home on short notice. Because when we get close up to these assessments deadlines, sometimes it's a same-day thing, and I don't want to have to figure out like opening up that computer to, anyway. So I needed it to be a little easier. So we just went with Python, specifically geopandas, because I was already familiar with it. So here comes all the Python stuff. I'll touch on the essentials here, but we set up our environment, which is just bringing in geopandas. We call some NumPy and pandas functions directly, so we get those too. I don't really need maps in this. I don't want to see a map because the map is the input layers. Those shouldn't change. But it's helpful for some QC stuff or just figuring out why the numbers don't line up. So I do bring in these other things for viewing intermediate outputs and just outputting files. We define the spatial reference. Sad truth is Kendall County is still very much an Esri shop. I am working on that, part of why I'm here. But some of these layers, they're still sitting in a feature service. And yeah, I know Esri has like a Python API. That's cool, but I don't want to use it. I don't want to touch it. I want this to be, I want to be able to point this at another data source, a different database, even a file if I had to, and have it still work. So geopandas is great for that. For us, we just tack on the requests library and we just ping these different services. And then we just throw those into a file when we're done. Getting the parcels was pretty easy. We're always working with a list of parcel numbers. So I have, this is just an example, but I have my parameters, or I'm just saying it's got to be, this is what the parcel number's like, and it should be a agricultural farm property class. And just give me the fields I need as a GeoJSON. And then GeoPandas can just read that and gives us, you can't see this, but you plot it, there's our parcels. So that's my starting point. And I wrote this a while ago. GeoPandas can handle pretty much anything. Shapefiles, zipped or unzipped, file geodatabase, geopackages, GeoJSON, direct PostGIS queries. If it's not in Postgres, if it's in something else, you can query it and pull it in separately. But and now GeoPandas is moving towards PyOgrio. I don't know if that's how you pronounce it. Anyway, Ogre bindings in GeoPandas, and it's way faster and cooler, and this list is probably longer than that. But, I wanted to make sure that I could hand it off to another county who's interested. Oh, but we keep this as geopackages, or we have a PostGIS database. Well, you could still use this. You just have to tweak a few lines. Getting the soil and land use for our intersections, I don't want the whole layer because they're gigantic, but I don't have attributes to filter on. I just have a spatial area. GeoPandas is great, so we can just say, grab the total bounds. So just your box envelope. ArcGIS server wants it to be formatted a certain way, so I just do that. But when we go to query those, I just throw that bounding box into the query. So it's only going to give me things that intersect with it. Importantly, if you're using other file sources, a lot of the GeoPandas reading methods support bounding box filters as well. So this would still work even if it's a land use shape file. I mean, heaven forbid, but it happens. And then there's just some quick field stuff because some of the values are goofy. But then I visualize the layers just so we can see that, yeah, we've got parcels, soils, and land use for that area. You can see the soils features can get quite complex and fun to look at. So I can see everything's here that should be. And I can proceed with some of the actual GIS. Except first I have to deal with this. In Illinois, I'm sure other places too, but you are taxed based on your deeded acreage. And again, that should never change. And thankfully, nobody's called us out on those shifts earlier, and we're trying to fix them. But if your deed was written in 1840 and they said it was 40 acres, and it turns out it's actually 37, it doesn't matter until you get a survey that says otherwise. You're being taxed on 40. Some people get a nice deal out of that. Some people are getting the short stick, but that's just how it works. So they're not equal. But once I run this intersection, how do I know what that little piece of the parcel should be worth? I only have its actual shape. So we just need a ratio. If we take the ratio of the part to the whole in measured area and then multiply it by the acreage for the whole thing, we're going to get the representative portion of that deeded value that the shape represents. So before I do any intersection, I just create a new field where I'm telling GeoPandas, take the area of the shape and just put it in here. And that's, it's 7 times 10 to the 6. It's a big number because we're working in state plane. It's square feet. We want acres, but since it's a ratio, the units cancel. Doesn't matter. As long as what I calculate here and later are the same units, doesn't matter. So we'll actually do the manipulation. We do a spatial overlay that's really nice and simple. It's just geopandas.overlay, and your input, you do 2 at a time, so I just put them together. And it's outputting this. So now we've got our parcel number, our acreage, the calculated area, but also the soil type, soil name. I don't know. This doesn't do side scrolling, I guess, but there's other fields off to the right with land use. I don't need most of these fields, so I just tell it, here are my keepers, drop everything else, and then I did not. Come on, font. Well, anyway. Oh, there it goes. So we got the land use type, the slope, and the geometry still. And then we just calculate the area of the different parts. And what that looks like is taking the area, the actual calculated area of each shape, and dividing it by the calculated area of the whole, and multiplying it by the gross acreage. Plot it out, that looks like this. So we're just making sure that each part has its representative acres. Now, one of the key goals is making sure this is accurate. So we can introduce validation steps. So if I have all of these parts that are supposed to represent portions of that parent parcel, they should add up to the same acreage, right? So that's what we're doing here. We're just going to do an aggregation using pandas, and I am rounding it off to 4 decimal places because that's all the assessments database can handle. And if I can be more precise, but it won't benefit me any. And so that looks like this. And I can see, I created this diff column just to see what the absolute difference is. And it's 0. So great, I have an accurate intersection and calculation here. Now, sometimes there is a value there that isn't 0, and I have to know, well, what's different here? And the soils layer, that's coming from NRCS. The state says that's a valid data source. They do say people can provide their own soil samples. Nobody's taken us up on that, thank goodness. And then I can just do Surgo soils. But so if there's a gap, it's going to be parcels or land use, and those are both me. So I need to know what's going on here. Geopandas can do an overlay of symmetric difference. So I can just see where are the areas where only one layer exists and not the other. And just show them to me. So there are little slivers here where the features don't align perfectly, but their area measures basically nothing, and it's not affecting things when we round to the 4 decimal places. So, and usually these are going to be roadways. The parcel extends into the roadway or it stops just shy of it. As long as it's not a measurable difference, we can move past it. But if there was a big gap, I'm going to see it on here and go edit the layer, start over, and it goes away. And then we just tidy up and export. So that assessments database, it actually handles steps 5 through 10 internally. And it's a proprietary thing. I don't like it. It's not my choice, though. But they expect a certain import format. So we just drop the fields we don't, and we do some manipulation for the fields because it looks like a numeric code, but it's actually a 0-led string. I hate it. But anyway, sorry, it started advancing over here. Okay, but this end of the day, this is the format that we need it to be, and then we just tell it. Oh yeah, there's another step. After this intersection, we might have 5 features that represent the same unique combination of soil, slope, and land use, and we don't need to separate out each unique instance. We just need to sum them per. So we just do that. We aggregate. So for each unique combination, there's only going to be 1 row. And we have the acreage of the part. And again, we have some issues where some of those intersections, just like we had tiny slivers where they didn't, we're going to have tiny slivers where they did overlap, and places where the acreage of the part is 2.5 times 10 to the minus 7. That's a very, very small piece of land, and it's not going to affect the output. So we actually just drop anything that is equal to 0 when rounded to 4 decimal places. We check it again to make sure that those numbers are still adding up, and as long as they do, we just export it to this tab separated value text file that we import into some arcane black box, and then valuation happens. I didn't like that. It is not my call what the assessments office does, unfortunately. When I told them you're changing deeded acreage values, they said that's not a bug, that's a feature. You need better imports, and they're right, I did, but I'm still mad at them. They're not nice people. But I still wanted say you're the farmer and you want to know, why is my tax bill this? I want to be able to say that even the assessment software is correct, even if I can't change it. Publication 122 gives me the steps for valuation. Unhelpfully, they provide the extra tables as just PDF. And so if you're feeling in need of punishment, you can digitize those to CSVs yourself. Nobody in the state of Illinois has thanked me yet, but you can just load them in from CSV as these. The soil types really shouldn't change. Actually, neither of these should change, but the coefficients might. And they say, when you've got a range of slopes, you can just take the central value, so we do that. And I'm kind of speeding through here because this is really specific to Illinois, and it is just math. But they tell us, how are we going to calculate the equalized assessed value, the actual dollar amount per acre? And it's one of these, whichever is greater. And then they only provide the numbers down to a PI of 82. But values lower than 82 are possible, so then they tell you how to calculate lower values yourself. They could have just given us that. And when you do it, when you calculate those lower values, it turns out even a PI of 1 is still above that floor. So even though they say whichever of these is greater, and they will always be greater than this one. So I don't know, but it might change some year. And then we just use those to merge in to our original data set. I lost my cursor again. Okay. And so now we've got, our soil types, our uneroded coefficient for favorable, unfavorable, all this stuff. And so we do a little bit of NumPy because whether it's favorable or not, it's going to change. We do more math. And then we've got an average PI as an integer. It's fine to just round those. And then using the average PI, we can then join in the EAV. And that is our dollars per acre. Except not, because we have land use adjustments. So you do more math, or you just take a floor value depending on what the land use is. Then you multiply it. And then you get your EAV per acre for the different things. So now for this particular soil type 101, slope A1, land use type 06, it's actually not worth anything because 06 I think is right of way, but 02 is cultivated farmlands. So it's a nice big chunk, it's worth a good amount. And it's soil type 101, perfect slope, it's a valuable piece. And then we can take the per parcel numbers and just sum them. And so now we've got, for every parcel number in our input, what the total assessed value of that property is. And then I can look at what that black box spit out when I imported the file and just see, like, well, how's it compare? And okay, they're just rounding to the nearest $10, but otherwise we've successfully validated the county's proprietary software. So we at least have the assurance that, yeah, we can't tell them to use a better tool for assessments, but at least for this portion, they're doing it right. They're doing things in accordance to publication 122. Taking these further, it does exist as a standalone function that takes different kinds of inputs, and it has validation warnings. It can write things to a file or you can define an acreage tolerance. We do stuff like that. I thought about maybe wrapping it in a GUI and just handing it off to people if they're interested. Maybe do stuff in the cloud, I don't know, or per parcel reports for farmers who are interested. And I've presented this at multiple Illinois GIS conferences, and every year there's somebody who's like, were you talking about DevNet? And I go, yeah. And were you talking about the Bruce Harris tool? And I go, yeah. And they're like, please give me your tool, because I hate those things. And so I've been able to get several counties off of those systems and using a transparent, replicable, accurate system. So we're improving the state a few few counties at a time. I'm open to any questions. I appreciate you guys spending the time to sit here. I know there was a Paul Ramsey talk, and I'm flattered that you chose to sit here and hear about this instead, and be in touch. Thanks.